Hello friends, today we are discussing the backbone of high-speed rail, signaling and control systems. Historically, train drivers relied on wayside or trackside signals, especially traffic lights for trains. However, at 300 km per hour, spotting a signal through a rainstorm or fog is nearly impossible. This is where in-cab signaling comes in. Instead of looking out of the window, the driver sees the signal status directly on their dashboard. Look at the utility here. If a train is approaching a red signal and that signal turns green, a traditional driver wouldn't know until they could physically see it. With ERTMS, the update is instantaneous. Systems like Euroloop or radio infill ensure that the onboard equipment is fed information constantly, allowing for smoother and faster transitions. Efficiency gap. There is an interesting technical paradox in ERTMS. In traditional systems, an amber light often means a hard gap. For instance, 160 km per hour in Spain. But ERTMS is smarter. It looks at the actual length of the track block ahead. If the block is long enough, ERTMS might allow the train to pass at the same amber light at a much higher speed. However, this creates a conceptual challenge. Imagine being a driver for 20 years, amber has mean 160. Suddenly, the computer says you can go 200. This can be confusing and even stressful. Because of this, many line operators chose to dumb down the ERTMS system to match old rules, just to maintain operational consistency. The technology is capable of more, but human psychology often dictates the pace of adoption. ERTMS Level 1. Let us look at ERTMS Level 1. Think of this as a hybrid layer. In Level 1, we still rely heavily on the physical infrastructure. The movement authority, which is essentially the permission for the train to occupy a section of track, is tied directly to a physical signal. The train gets its data in chunks as it passes over Eurovalues in the track. It is a massive step up for legacy systems, but it is still constrained by the physical placement of these signals. ERTMS Level 2. Now Level 2 is where we truly enter the digital age. Here we move from intermittent communication to continuous communication via GSM-R radio. In Level 2, the driver does not need wayside signals at all. In fact, one lines built exclusively for Level 2, you might not see any signals on the trackside. They can be entirely absent. Because the link is continuous, we don't need infill devices anymore. The train knows the moment the path is clear. This allows us to pack trains closer together, right up to the final track circuit occupied by the train in front of you. The Spanish case study. Spain provides a fascinating case study in safety culture. Even though their level 2 lines don't need trackside signals, they have kept them and even invented new aspects or light patterns for them. Why? to prevent habituation. They don't want drivers to get used to passing red lights just because the computer says it is okay. If a driver spends all day in level 2 ignoring a red trackside light, they might accidentally blow a red signal when they switch back to a level 1 or legacy line. It's a failsafe for human brain, ensuring that a red light always means stop in driver's mind. ERTMS level 3 moving block. Finally, we reach the holy grail, level 3. The primary innovation here is the moving block. In level 1 and 2, the track is divided into fixed sections. Only one train can be in a section at a time. In level 3, we throw the sections away. The block is simply the safety envelope around the train itself. This increases capacity exponentially because the distance between two trains is reduced to the absolute minimum requiring braking distance. The tracks are no longer empty space. They are utilized to their maximum potential. Precision and safety in level 3. How do we stay safe without fixed blocks? It comes down to train localization. In level 3, the train behind is permitted to drive right up to the tail of the train in front. To do this safely, the system calculates a worst case scenario for where that tail actually is, accounting for any small error in GPS or sensor data. This is the biggest technological hurdle for level 3. The train must be able to prove with 100% certainty that is still whole and hasn't left a carriage behind, as there are no track circuits to detect a raw wagon. Okay, thank you.